Hello, everyone. Welcome to the fourth session in Columbus McKinnon's Safe and Sound Speaker Series. I'm Megan Voss, a marketing manager here at Columbus McKinnon. Safe and Sound Week is led by OSHA, and it's a nationwide event held each August. It's designed to recognize the successes of workplace safety programs and offer information and ideas on how to keep America's workers safe. So Columbus McKinnon is recognizing that effort with this speaker series on safety. Our final session tomorrow is on safety and entertainment rigging. Check the chat for a link to the registration page to sign up for that session. Every session from this week is being recorded and will be available on our website as a blog article. I'm so glad you could join us today for our session on crane controls. We'll be discussing some of the safety issues at manufacturing facilities and the roles crane controls can have in reducing the dangers of these hazards. So we're going to have a chat today for about 30 minutes, and then we'll open it up for questions from you, our audience, at the end. And you can submit your questions into the GoToWebinars questions pane, and we look forward to hearing your thoughts and questions. I'm joined today by Bob Schmitt, Casey Cummins, and John Walters. Bob is the Business Development Manager for Controls for Columbus McKinnon. He's been with the company for 36 years in a variety of positions with increasing responsibility, beginning in inside sales and transitioning to product management, and now his current role, where he's focused on providing solutions to our customers' challenges and opportunities. Casey Cummins is the Controls Product Development Manager, working with the Controls Product Development team to develop safe and innovative AC and DC controls for overhead crane systems. He has held roles in software development, electrical design, and project management over the 10 years he has been with Columbus McKinnon. John Walters is our Senior Sales Application Engineer and Technical Trainer. He has nearly 30 years of experience in the overhead crane industry, working in a variety of areas in our company, including drive repair, tech support, and sales application engineering, and then leading to his current role as an expert product trainer for Columbus McKinnon. All three of our speakers take an active role in developing our industry by participating on technical committees and in industry associations, and I'm very excited to talk to them today about an area of expertise they all share, crane controls. Casey, Bob, John, thank you so much for being with us today. I'd like to start by asking Bob. Bob, I know you often go on site at different manufacturing facilities. When it comes to in-house safety hazards, what do you see are the biggest concerns?
Okay, first of all, can you hear me? Want to make
yes,
sure everybody can hear me? Okay, great, thank you. Yeah, first I want to say thank you for this opportunity to talk during the Safe and Sound Week. Really appreciate this opportunity. But yes, throughout my many years working for Magnatech and now Columbus McKinnon, I've had certainly a lot of opportunity to see a lot of different manufacturing facilities over the years, seen a lot of things. Many of these facilities that I've been to have very stringent safety standards incorporated in their daily process. A few of them, I'll say, there might be opportunities for improvement, let's say. But I think we can all agree that when we're talking about overhead cranes, they're very significant machines that are overhead in a manufacturing facility, and the safety around these big machines can't be overstated enough. There's definitely a few things that come to mind when I think about safety and some of the I'll say dangerous situations at some of these applications. I think Megan might have a slide that she'll be bringing up here. But one is overloading of a crane. There's a few talking points we want to cover here. One is overloading of a crane. I don't want to say it's standard practice, but we definitely see it out there enough where it is certainly an issue. We see this more often than not in older crane applications with older antiquated control systems that don't have the ability to sense torque or sense current to limit the loading on the hook, or at least some sort of feedback like a load cell device to give the operator some sort of indication as to the load on the hook. Another situation is swinging of a load. Whether it be unexpected or uncontrolled movement of a load due to excessive sway, that certainly can cause an unsafe or dangerous situation, not only for the operator themselves, but any personnel in close proximity of the traveling load. This is something that's probably more common in high throughput applications. You know, today's manufacturing facilities, they're very busy and they're trying to run as fast as they can in many cases. Also see this in certainly higher running speed applications and certainly with operators that might have a little less experience. Certainly opportunities for improvement there, no doubt about it. Other situation is crane collisions. So we're talking about either cranes colliding with the wall, crane to crane collision, or there's cases where you might have multi-level cranes where you have a crane that rides over another crane. So if you can picture this, if the top crane has the rope down, it might be attaching a load down at the floor, and then the lower crane has the ability to impede with that wire rope. Certainly can cause a very dangerous situation. In fact, I know of one scenario that there was a gantry crane underneath a top running crane, and they had instances where either the top crane with its rope down would collide with the gantry crane below, or vice versa, the gantry crane would collide with the rope from the upper crane itself. And I think that caused some injuries in that application. But you can picture there's many different applications where you have a crane collision potential, I'll say. And then the lastly, dropping of a load is certainly something that probably doesn't happen as often anymore, as more and more cranes are being upgraded with newer technology that helps to prevent that. But from what I've heard in the past, and the cases that I've heard about, certainly where you drop a load, it usually involves an older crane with older controls, situations where you've had multiple failures at the same time, which certainly doesn't happen very often, or maintenance issues that have gone overlooked for a period of time. But again, all these applications that we talk about, these opportunities for improvement, we'll say, certainly things that are curable. There's technology out there today to help prevent these things from happening in the first place. And keeping up with your day-to-day normal recommended maintenance of the cranes will also help prevent much of this. I hope I answered your question there, Megan.
You did, Bob. Thanks very much. I want to open it up to John and Casey. Do you guys have any real-life examples you'd like to share? And also tell us, why can these situations be so dangerous?
Well, I can reinforce Bob's last point regarding dropping of a load. I had occasion some years ago to go out to a facility to do training, and prior to my arrival that night, they had a load fall. Of course, we're very fortunate nobody was injured. There was equipment damage and material damage, but there were no injuries in this event. The situation was a compilation of a number of things that went wrong all at once. And we're very fortunate that at this facility, they had an excellent safety department that had records of previous contributing factors, and the maintenance department also had logged a number of things as well. The crane operator that was operating the hoist at the time was also available. I came into play. I walked in totally blind, and it was very fortunate that we had a drive on the hoist, and using the fault history and fault trace data, we were able to peg down exactly what was going on in conjunction with the material the safety department had at their fingertips. And within short order, probably less than an hour, we had, or I should say, they had a corrective action policy in place to address the issue and prevent it from happening again.
Yeah, and I guess another couple things that I can think of, situations that I've heard about certainly in the industry before, and I've heard these from reputable sources regarding a dropping of a load. I know of one application at a steel mill where they actually dropped on a hot metal crane, they dropped a load of molten metal, and as you can imagine how dangerous that would, the scenario that creates for sure, and the amount of downtime involved in trying to clean that mess up. I don't believe that there was any injuries or fatalities that I'm aware of, but you can certainly imagine how dangerous of a situation that can be. As it relates to colliding cranes again, there's another one that comes to mind that I remember a customer telling me about is there was an application where a crane was running at full speed, went through the end stops, blew through the end stops, went through the wall, and the crane ended up out in the parking lot of the facility out and back. So, there's certainly a number of opportunities for improvement there. Certainly a training opportunity, no doubt, and obviously there was either a failure of the crane end stops, or potentially maybe they were undersized to begin with. Who knows? But yeah, definitely a few opportunities for improvement there, no doubt. But no doubt a dangerous situation.
That crane that ended up in the parking lot, they probably picked it up, put it back on the rails, and were up and running in a couple hours, right? Or were they down for months?
I'm sure of that. Yeah. Well, certainly picture that. So obviously that crane, if they could even work with it again, probably needed a lot of work. The runway probably needed a lot of work, and the building needed to be repaired. So, that one little incident probably caused surely a lot of downtime, no doubt about that.
And dollars, right?
And dollars.
One other thing that comes to mind that I've had occasion to see is, for whatever reason, there's a tendency to do, I'll use the term side pulls, where somebody will actually not completely lift the load up off the ground, but rather, for lack of a better term, drag it with the trolley and or the bridge. And there's a number of issues with this. The first one that comes to mind is the mechanical damage on the crane structure itself, whether it's the shafts, the gears, the actual crane structure components, those types of things, as well as a motor overheating and that type of thing, and actually damage then to the load that's being manipulated across the floor. And these are something else that one should be aware of. That's not a good practice in the real world. Something that after a number of side pulls, it is strongly recommended that the cranes themselves be inspected. So we're looking for stress cracks. We're looking for problems in the gearbox or shafts, couplings, all of those types of things. When the crane is rated for a particular load, that doesn't include fighting the pull of gravity with said load as it's being pulled across the floor or ground or whatever the case may be.
Yeah, there's certainly some applications that I've seen out in the field where they're using the crane to flip up slabs. Like they got a slab of either concrete or steel or aluminum, whatever it may be, and they use the crane to turn it up so they can lift it and move it. And if the crane is designed to do that up front, it has the safety built into it already. But in some cases that is not the case. And obviously that side pulling that John was just referring to can cause a lot of additional wear and tear on many of the mechanical parts of that crane. So yeah, I agree with you, John. Thank you.
Yeah, and just to reiterate real quick on that, if the crane is not inspected when it's used in this manner, one can probably expect mechanical failures and a resulting event from that, whether it's a shaft or a coupling that gives way, crane structure failure, those types of things.
Well, thanks, guys. Thanks for all those great examples. It sounds to me like it's just crucial to build in safety from the beginning and have regular maintenance and inspection practices instead of reacting to one of these terrible incidents and trying to clean up from that. John referenced earlier about checking the available drive history and faults at his visit. I want to ask you, Casey, how does drive technology address using these hazards?
Yeah, thanks. I definitely want to nail down some of the solutions and technology that'll help address and hopefully eliminate these common hazards in the crane world. So let's start with the overloading a crane. Your crane will obviously have a certain capacity and likely have the weight plastered on the side of it somewhere. But how do you know that what you're lifting isn't beyond that? Or maybe you have a load that's bolted to the ground accidentally. It happens. So what can you do to prevent that and prevent it from damaging your crane and harming people? The easy answer is a load cell, or essentially a scale. That's one of the most basic pieces of equipment that you can at least get an idea of what weight you have on the hook. They can be inexpensive. Some of them are really expensive, depending on your capacity, your precision. I've heard of an application that had a really high capacity crane. The load cell was tens of thousands of dollars, but the load cell was down towards the hook in a rough application. They have been steel, and it's getting beat to death, and they fail. So you can only imagine replacing it. Tens of thousands of dollar load cell occasionally. So it's still a good solution, but there's some other things that are up and coming that can be even better yet. One of them is to use your drive. So if you have a digital drive, VFD, that typically measures what's coming back from your motor. And if you have a closed loop solution, you can measure the motor torque, and that can be equated into a load profile. So essentially you measure the weight based on the loading of the motor. From there, you could display that weight on a scoreboard. You could calibrate overloads on multiple hoists, sum them together, and it's a really good inclusive way of protecting your entire crane. And then all that built into your controls that you don't need to maintenance. Another option could be a PLC. PLCs have been around for decades. They're not the big scary black boxes that they used to be. So in our experience, we're seeing people really reduce the complexity of their control systems, especially during a modernization. And then really the sky's the limit for what you want to add as far as safety and productivity features. So generally, less complexity is less probability of failure. So we really take that to heart. The next subject was a swinging load. And hoists in general are just badly affected by the pendulum effect. So you get a load up in the air, suspended, and then just the basic movement of it can get it swinging all over the place. I've seen that there's some really talented operators out there that can counteract that, and it's quite a feat to be seen. But I don't think there's many of those around, and probably don't want to rely on that. So there's some solutions out there. You can get solutions built into a drive, PLC, typically they're called sway control. And what that does is it predicts and counteracts your pendulum effect of your load. So for the most part, it's just pretty simple, straightforward math based on Newton's second law of motion, which predicts the motion of a pendulum. So I don't know if you'll be able to see this on the camera here, but picture this as your hoist. So when you move, the load due to gravity slightly lags your bridge or trolley motion. So that gets a head start on it. And as it gets pulled, it'll swing forward. And as you stop, change directions, this thing just is reactive and all over the place. So what sway control can do is your bridge or trolley will move forward, and then it'll pause and wait for that load to swing forward and then smoothly accelerate. So it's pretty slick, and it just right away, almost like magic, takes all that swing out of it. So it can make a huge effect on placement and then just not being able to know where that load is swinging with people around. So it eliminates all that. The third one is collisions. So whether that's crane to crane, crane to wall, there's a lot of different sensors out there that are really inexpensive that for pretty much any environment. You've probably heard of laser-based systems, LED, IR systems. You can get these things for on the scale of $100 even. So in our eyes, it's a huge boost in safety for a small investment. So then the operator doesn't need to constantly be monitoring other cranes, where the wall is, and just focus on what's important, operating, and let those sensors monitor in the background and protect the crane and operator. We see that radar is going to be an up and coming technology in the automotive industry. Everybody's going crazy with collision avoidance, and radar is one of the common sensors out there that we're seeing. So the great part about that is that they're producing these sensors in the tens of millions, and what used to cost $10,000 is going to be in the hundreds now. So we're really excited to see where this is going to go, and it's going to open up some big opportunities for harsh applications where there's dust in the air, outdoors, so the sun and rain, the environment doesn't affect it. So there's a lot of gaps out there that are still open to be solved. So we're excited to see where that goes.
Yeah, so let me chime in, Casey, if you don't mind. Yeah, picture this, the application I referred to before where the crane blew through the end stops, went through the end of the building, ended up in a parking lot. I mean, that probably realistically ended up costing that company tens, if not hundreds of thousands of dollars. All that could have been avoided with probably a couple $100 collision avoidance sensor on that crane. So that's how a small cost can really make a big impact in a scenario like that.
Absolutely, and it's really the simplest of all these. You don't need to drive. If you have an old 1800s contactor control crane, you can put a laser on there. That's simple. So it's, if you're going to add safety, I would recommend looking at that one as number one. The fourth and last topic was dropping a load. So I'll address that one. And I think it's really telling that both John and Bob, their initial stories they had were about a load being dropped. Those are the memorable events, and in my eyes, that's the scariest thing that I'm most nervous about when I'm around a crane. You get anywhere near that load, you're always wondering, is that thing going to stay up there? And you don't want to be anywhere near it.
Amen to that.
Luckily, with the technology of drives and PLCs over the past several decades, we've really seen a decrease in those occurrences from happening. Yeah, we remember them, but they're not happening every week, every year even. So we're making good strides and want to keep improving on that. So the question is, how'd that happen? How do we make progress on it? And using a drive on a hoist, if you have closed loop control, you have an encoder. So what that gives you is feedback, and you can monitor exactly where your load is at all times. If you have a torque proving in your closed loop algorithm, it'll check before it even opens the brake that your drive and controls can actually hold the load before you open those brakes. And then inversely, at the end of a run, before the drive hands over control to those brakes, it checks that it can hold it. So that's all due to just feedback on the drive and what it can monitor. The technology has definitely come a long ways, and it's keep going further, especially with the dawn of automation.
Okay. One other thing I'd like to touch on is before we move on, regarding the overloading of cranes. Again, this is kind of a common situation that happens out there. I just want to bring up the fact that most prepackaged hoists or even some of the built-up hoists out there are coming with that technology already built in to prevent you from overloading, prevent you from an overloading condition anyway. So there is technology being employed in most modern applications. It's primarily the older cranes that we're seeing these situations primarily. Now, John, if you have any input on that, you probably see a lot out there in the field as well.
Well, yeah, again, some of it is all different manner of things that can cause this. One could just be lack of knowledge of what they're picking, or it could be the item they're picking is, I use the term, it's bolted down to Mother Earth, and they're trying to pick up Mother Earth. And a simple, inexpensive device would really eliminate a lot of these issues, and it could do nothing but turn on a light bulb all the way to prevent the lifting of the load until the amount of load that's attempted to be lifted is reduced. So all of this technology is out there. Okay, so the other, I'll leave that at this point, Bob. How's that?
Thank you.
Well, thanks, guys. That's some great information to share. Of all those issues that Casey was talking about that the technology can address, which ones do you experience most often in the field?
I can attest to the fact probably the most common problem is collision, okay? And this can be anything from bridge crane to bridge crane collision to multiple trolleys running along the same bridge colliding. And it's through no fault of the crane operator. In today's world, there's a lot of stress for everybody in a production floor. Basically, it's to increase throughput, productivity, increase profits. And to be quite blunt, the crane operator is focused on the load, right? That's the item that can, perhaps we'll use the term, do the most damage. It's also the item that they must be careful with. And if they're busy watching that, they may not know what's going on up above them on the bridge, on the runway between two bridge cranes, between the end stops, as Bob had mentioned, or between individual trolleys running along the same bridge. And collision avoidance is, again, a relatively simple thing to address, and it eliminates damage to loads, mechanical damage or structural damage to cranes, as well as, of course, priority, that would be safety.
Thanks, John.
I guess I would like to
Sorry, Bob.
probably agree with John. Probably the most common things that I see out in the field, certainly out of these issues that we're talking about, are overloading of the crane and crane collisions are probably the two most prevalent situations. I would agree with that.
Thanks, Bob. So, John, you mentioned, how much the crane operator has to do, as part of their role. But I'm sure they play a role in ensuring the safe environment. So, Bob, can you talk a little bit more about the crane operator's role and how technology works with his or her skills?
Yeah, absolutely. So again, like John kind of alluded to, today's manufacturing environments, they're looking for more and more throughput. Hopefully the cranes had that designed in the beginning. Cranes were designed that way in the beginning from the get-go, but a lot of times the operators now are being tasked to move more product faster, and they're having to worry about a lot more things. They got to worry about cranes colliding and overloading of the crane and all these other scenarios we just talked about. But with today's control systems, with all the technology that is available and out there, incorporated in today's VFDs and all the other collision avoidance sensors that can be offered, there's a lot of technology out there that takes the onus off of the operators necessarily, so they don't have to worry about necessarily, gosh, do I have too much load on that hook, because now there's a device to prevent them from lifting that load, or at least give them feedback as to what is on the hook. There's devices out there that'll keep the cranes from colliding, so they can pay attention to what the load that's on the hook more, certainly to help make the process safer, no doubt about that. I don't know if that answers your question or not.
The two sides that I see on this are, how do we use technology to protect today's crane operators? The other side of it is, how do we engage new people? So as the workforce is aging, retiring, there's new people that need to fill those gaps. So what can we do to draw people into it? We'd be dishonest with ourselves to say that the crane industry is super safe, so that might stray people away from it. So we can definitely use the technology from today to make it a lot safer, make people less nervous, and then have new operators have less opportunity for failure. And then the other side of it is, how do you get people engaged? So me, I'm a millennial, so I grew up with video games and computers progressing, and the newer generations yet grew up with Snapchat and Facebook. So attention spans are pretty short, but we could also pretty much drive a crane with an Xbox controller. So it's not too far from the truth. So there's a lot of neat, fun things that we can do in cranes that, not only make it a dull industry, but to make it fun and safe and engaging.
Great, thanks, guys. That's some great information. I want to move on and talk a little bit about requirements. Can you talk to me about any safety-related requirements for cranes and crane controls?
Yeah, I'll take that one. That's a good topic. So there are a lot of industries out there that deal with the crane manufacturers. So there's AIST, another one is CMAA, which is the Crane Manufacturers Association of America. They have committees that build standards, and they've been doing this thing for decades on all the necessary parts of a crane. So I have one of them here, CMAA 70. So this is a little bit of an outdated one, but it's specifications for overhead electric cranes. So actually, this is the part of the show where you guys get your money's worth, because we are going to read this thing from cover to cover. So get comfortable. Just kidding. It's really the point of this is to set some consistent standards for how people build cranes. So in the US, CMAA is really popular. And if you were to buy a crane built to those standards, you know that you're going to get something that's predictable and consistent. One of the points that it really doesn't hit on are many requirements. So it gives you a lot of good minimum design standards, some electrical and control recommendations, but you still have to take it on yourself to investigate these things. And that's why I want to recommend some of these really easy adder safety technologies that nobody is really requiring, but we seriously think that everybody should be looking into these things. I will note that I actually just noticed this week, but the brand new 2020 version of CMAA 70 came out. So the really cool thing about this is in the first couple pages, it conveniently gives you what's changed since the last one. So the last one I think was from 5 or 6 years ago. So some cool stuff they added was sections about wireless data transfer, application of regenerative systems, IEEE 519, that's a fun subject. They even added some wiring practices for inside or outside your enclosures. So again, these are all just suggestions, and I like it because it gives somebody a lead of where to start. That might be the hardest thing, is you want to build or buy a crane, where the heck do you start? Some of the sections, they also have a big section on electrical. So all this stuff in here. And as we talked about earlier, they have a section on variable frequency drives, remote controls, collision avoidance, weigh scale systems. So a lot of the stuff that we hit on today, there's really good information and recommendations in this book. So if you're not aware of it, I would definitely take a look at it. It's some good information. So just to reiterate, there's recommendations, and unlike the auto industry, which is mandating stuff, for example, backup cameras, those I think have been mandated for a couple of years now. Collision avoidance sensors, those are everywhere now, and I think those are going to be required in the next couple of years. So they're really forcing everybody's hand, but it's having a huge safety effect. I think that the crane industry should do something similar and make some of these technologies required as well. I don't think it'll happen, so that's where we come in. It's something like a really inexpensive collision avoidance sensor. You know, that could be a couple $100 investment that saves lives. So it's a good idea. We're serious about it. We'll make a plug here that all of us on the call are actively involved in these industries. I'm involved with the AIST, which is the Iron and Steel Technology Committee. CMAA have helped review some of their standards, and it's a big group of end users and suppliers that all work together, all share ideas, and even though we might compete together, we're all on the same team here as far as creating and solving the goal that we want to add safe technology, safe products out there, and keep progressing our industry, making it safer.
That's a great point, Casey. I just want to reiterate there's a couple people in our company that are involved in some of these different standards that are out there. But one thing I want to mention is when a end user goes out for a bid for a crane, and this is where these standards really come into play, I think, is when they go out for multiple bids from different crane companies, and as long as they're building a crane, let's say to the CMA standards or AST standards, or there's NOG for the nuclear industry as well, you know that they're at least designing a crane with a minimum standard, so it kind of makes a good comparison between the cranes. As long as they're building the cranes or designing the cranes to these standards, these minimum standards. Again, there's a lot of other safety features that Casey was touching on that could be incorporated in addition to these standards, but at least the minimum is there, I guess, worth pointing out. Thank you.
But in all of our discussions here, you know, we've talked about safety and all the rest of this, and we've got, I guess, our most important concern is human beings, right? And we've talked a little bit about the crane operators, but the other thing that one should address is what about other personnel that will be on the shop floor in close proximity to or in the runway of the crane itself or the load on the crane. So as an example, there could be a runway, a traffic pattern where forklifts drive through. And we want to make sure that we don't cross over that if there is human beings or a forklift in close proximity to that. The technology exists for things like this, okay? You know, the load is important. What's hanging on the end of the hook is important. There's a dollar value to that. There's manufacturing hours put into that, and all of the rest of that. Human beings, though, should probably be number one, and they are number one with respect to these standards that that Casey and Bob have described. And with the technology that's out there, we have the ability for comparatively low dollar amount, very inexpensive for what they would save in the long run. So everybody comes home safely. It comes to the matter of why wouldn't one look at investing in technology to enhance and further take safety to the next level. That's what I'll throw in at this point.
Thank you, John. You're right. That is the most important thing, that everyone goes home safe and sound at the end of the day. So thanks, guys, for all of that great information. We're going to open it up for questions now. So just a reminder, you can type your questions into the GoToWebinars questions pane, and Bob, Casey, and John will address those. So our first question here, it's a scenario that somebody has in their factory. They're using a pendant to move their crane from one end of the facility to the other. And it's in a very dangerous environment. So how could they make that safer?
Yeah, I'll take that one. So if I'm picturing this one correctly, it's an operator that has a pendant that's hanging down from their crane. So essentially they're tethered to it. So when they need to move the load somewhere else, the operator's there pressing the buttons, walking along with it. And not only do they have to pay attention to where they're walking, they have to watch what the load's doing. Maybe it's swinging around or trying to keep it away from other things. So pretty obvious where the challenge could be and the possible room for harm. One easy way to improve that would be to make it wireless. So instead of that pendant that you're dragging along with it, make it a radio control. Then the operator can be well away from this thing, have a better vantage point of what the load's actually doing. Another option could be just automating that whole thing. Say this was a pretty simple motion of moving a load from one end of the facility to the other. If it's pretty repeatable and consistent, you could just automate it and let the crane drive itself at the push of a button. That makes it consistent. You can make that inherently safe, and then that operator could be used in a more value add for the company. So a couple good options there.
Yeah, I'd like to reinforce the idea of the radio control. When the operator is not tethered to the crane itself, one of the big advantages is they can inspect the load. Let's say they're doing a 4-corner pick and they've got rigging. The crane operator has the ability to walk around the load safely, obviously, to inspect the rigging to be sure everything is what it's supposed to be in the process of making a lift. Whereas if one's tethered to a set spot, one may not be able to see all of the fastening points. So again, a handheld radio device really is a plus.
Thanks, John and Casey. I want to add on to what you were saying, Casey. You mentioned automation. And actually in Tuesday's session in our Safe and Sound series, we talked all about automation and how automation technology can be on safety. So the recording is available on our website of that session, and we're going to share the link in the chat. So check that out to learn more about automation. So let's go to our next question. It's about collision avoidance systems. Are there special requirements when using collision avoidance systems in Class 1 Div 2 hazardous locations?
I guess I can grab that one. I guess the answer would be yes. Yes, there is definitely things that you need to consider for a Class 1 Div 2 application in collision avoidance. First of all, yes, it is possible to do. There isn't that I'm aware of, there isn't a sensor already rated for that environment. So what we would have to do is take the collision avoidance sensor, mount it inside of one of our NEMA 7 or NEMA 9 enclosures with a window in it, and then you should be good to go. But it would require putting a sensor in an approved enclosure for that environment. But it is certainly possible to do, yes.
Yeah, just to reiterate that, I don't believe, at least I haven't seen any sensors itself that are rated for Class 1 Div 2. So I've seen some people that have almost made the mistake of putting one of those out in a hazardous environment. And a lot of time those sensors have a contact or relay built inside of them. So that's a potential point that could weld close or spark and then ignite something. So I'm sure for that reason, that's why they're not specifically rated for it. Maybe someday they will. But really the point there is, if you have that application, just look closely at the data sheets of the sensor.
Thanks, Casey and Bob.
Okay.
Question here. Are all chain type hoists, as opposed to wire rope hoists, required to have an overload device? Are there any instances where a remote operated crane, be it a monorail crane or jib crane, where a warning device is not required?
Well, that's a good question. I guess I don't know the answer to that one. I don't know if there's an absolute requirement on chain hoist to have an overload device. That's something I would have to look into myself. I'm pretty sure, I think I can safely say that most of them do. But as far as the second part of that question, I guess I didn't catch the rest of that. Well, could you repeat that, Megan?
Oh, sure. So are there any instances where a remote operated crane, be it a monorail crane or jib crane, where a warning device is not required?
What do you guys think?
Yeah, I'm with you there. I don't know if there's any warning devices required. There might be requirements of a upper weighted limit per se, so that you don't block your hoist and break the chain or rope. I don't think there's necessarily overloads, but you're right that a lot of them include that as standard because it's such a simple and easy thing to add.
Yeah, I plead ignorance on if it's a requirement, but it sure makes sense that one would want something like that. Absolutely. And as Casey said, it's a low dollar adder for a big savings in the long run.
Well, thanks, guys. Let's go to our next question here. Can an overhead lifting system, such as a crane, be used for lifting a guided load? For example, a door on a lard furnace.
See, I didn't quite catch that. Could you repeat that?
Sure. So can an overhead lifting system, such as a crane, be used for lifting a guided load? For example, a door on a lard furnace, L-A-R-D furnace.
I wonder if that means that not only does it have to lift it with the hoist, but it might have to adjust the travel motion as a door opens. Taking a swing at that one.
Yeah, so if it's a repeatable function, it shouldn't be too difficult to do. Again, this could almost be an automated system, I would think, Casey or Bob, right? If it's a repeatable, the This item is always in the same thing, and you have an overhead device, crane as it would be to when time is right to lift the door.
Yeah, definitely. That would be a good way to add your precision and move the crane consistently for opening that door every time. Sorry if we misunderstood that one.
Yeah, well, we can follow up with the asker and get a little more clarification and try to give them an answer. Let's move on to the next question that we have. ASME 830.11 requires warning devices for remote control cranes. Does the whistle meet this requirement?
Does a what meet the requirement?
Does a whistle meet this requirement?
I guess our standard for radio controls is talking about the horn function to when you power up the crane. I guess I'm not familiar with that exact specification, but we typically do have a horn function on all radio controls and pendant stations to meet a minimum requirement. I don't know if I'm answering the question or not.
Is the question, if the crane is in motion, do they need some kind of active warning device? And is a whistle, some kind of whistle being used, okay to use? I believe the spec says a quote unquote warning device. The warning device will be of whatever's choosing is. I've seen bells, I've seen electronic horns, I've seen buzzers, flashing, rotating beacons to back that up. I guess it would probably need to be, and again, I'm not saying for sure, but it would probably need to be addressed based on the background noise in the environment where the crane is running. So if it's, again, let's say a steel mill where there's a lot of, everybody's wearing headphones because of the sound level, that crane motion indicator, the audible indicator, must be such that one can hear it with the appropriate headphones on. And I don't think, aside from that, there's no real specification as to what it should be.
Well, thanks, John. We are just about running out of time today, so that'll do it for our questions today. But before we wrap up, I'd like to ask each of you, is there one thought that you'd like to share with the audience today? Starting with you, Bob.
I guess the only thing that I would want to touch on is the use of probably general purpose drives out in the industry. You know, a lot of times a facility will standardize on a certain, I'll say a brand of drives that may be considered general purpose drives, and they may be just fine on the equipment on the floor, but they don't take in consideration that an overhead crane is kind of a special application, that I would say, where you have a lifting application. The reason why I bring this up is there's a lot of safety features that the different manufacturers out there that have, I'll say, crane-specific drives, they put a lot of safety features into those drives as it relates to lifting of a load, as opposed to, you know, a general purpose drive that's designed specifically for running pumps and fans and things like that. Like Casey mentioned earlier, a lifting application is a little different, and we take it very seriously. And there's, like I said, safety features in there that proves that you have a motor capable of building up torque and making sure that your brakes are rated for the load, so that when you do have to set the brake, that the brake's going to be able to hold the load. For example, there's features like you know, making sure that we have torque proofing, make sure you have enough torque to lift the load so it doesn't come down, it goes in the right direction. There's simple things like that. What else? There's features that can be in the drive that might detect if your brake is slipping, and the drive can actually take control of that load then, if it detects that the brake is not in fact holding the load, and then it sets an alarm. And so there's all kinds of safety features built into what we consider a crane-specific drive as compared to a general purpose drive. I just thought that would be worth mentioning. Thank you.
Thanks, Bob. John, what about you? Any last thoughts?
Well, reinforcing what Bob had said, crane-related products, overhead crane-related products, including the drives, would optimize safety multiple ways. One, they're easier to set up than trying for you. I'll use the term massage the programming in a general purpose drive to get it to maybe work the way that the crane operator, crane user is expecting. Whereas a crane specific drive, it's set up, it's designed in the programming, the wiring, and outputs to interface directly with what one would expect in crane operation. Now, taking past that, there are other safety related devices supplied by crane manufacturers, basically distance detection, overload systems, radio remote controls. We've all just touched on these things, but these all would be what one would probably want to take a look at. The technology is there, it's available, and again, in my mind, why would one not want to use the best equipment possible to enhance safety?
Thanks, John. And Casey, last message from you?
Yeah. My main topic would be, if you're an end user, if you have a crane application, be vocal about your requirements and your challenges. Don't be afraid to reach out to us, to others in the industry. We all really like talking about this sort of thing. We like trying to solve applications, solve problems. We realize that applications are getting more complex, so we want to make sure that we're keeping up with the needs. So whether it's making a crane faster or making it safer, we like to just spread the knowledge out there and help everybody improve these things. So we've seen that the best innovations come from solving end users' problems. So we definitely take that to heart deeply.
Great point, Casey. I love that. Thank you.
Great. Well, that's going to bring us to the end of our session today. John, Casey, Bob, thank you so much for sharing your expertise with us today. A recording of this session can be found on our website shortly. There's going to be a link in the chat that you can use. And I'd like to thank everyone for being with us today. And I hope you join us for the last session of our Safe and Sound series tomorrow and explore the recorded sessions on the blog. Enjoy the rest of your day.
Great. Thank you, everyone.
Thank you.
Thanks.